In example 3, we are going to solve a system of linear equations with infinitely many solutions. If we take a look at our matrix, remember our first column is x, second column represents our y's, third column represents our z's. So this is our column of x's, column of y's, column of z's, and our last column is our constant. The first thing we're going to do is we're going to go ahead and rewrite these. So I'm going to rewrite this first one, and it's going to be x plus 2z, because I have no y's, and that's going to be equal to 4. My next equation is going to be 11 over 4x plus y plus 15 over 2z, and that's going to be equal to 4. And then my last equation, I have no x's, so I have 5y plus 10z equal to negative 35. Now what I want to do is I want to break it down to a system of two equations with two unknowns. If I take a look at the first equation, I have an x and a z. And if I take a look at the last equation, I have a y and a z. So if I want to use this first equation, let's say the x and the z, that means I need another equation with just x and z. So I can use equation 2 and equation 3 and eliminate the y. So let's do that. So if I'm going to use equation 1 and 3 to eliminate my y's, I can just multiply this top equation here by negative 5. Doing that, I get negative 55 over 4 times x minus 5y minus 75 over 2z, and that's equal to negative 20. And then my bottom equation I can leave alone, and I'm going to line it up correctly. So I have 5y plus 10z equal to negative 35. Then I can add these two equations together. There's nothing to add the x with, so this negative 55 over 4x is just going to come down. So I have negative 55 over 4x. Then my y's are going to cancel. And then if I add negative 75 over 2 plus 10, I get minus 55 over 2 times z equal to negative 55. So then I'm going to take this equation that just has the two variables x and z, and I'm going to take this equation that has the x and the z, and I'm going to put those two together. So I have that equation x plus 2z equal to 4, and my equation negative 55 over 4x minus 55 over 2z, and that's equal to negative 55. That's a negative. And then what I want to do is I want to either eliminate my x's or I want to eliminate my z's. I'm just going to go ahead and eliminate my x's. So to do that, I would need to multiply this top equation here. Let's move this over for just a second. I need to multiply this by 55 over 4 to get my new equation. So if I multiply that by 55 over 4, I get the following. I have 55 over 4x plus 55 over 2z equal to 55. And then my bottom equation I'll leave the same, negative 55 over 4x minus 55 over 2z equal to negative 55. And if I go through and solve that, my x's cancel out and my z's cancel out, and I'm left with nothing equal to 55, and negative 55 is also 0. So I'm left with nothing, but 0 equal to 0 is a true statement, unlike the previous example. So this tells me that I have infinitely many solutions. But now, since I have infinitely many solutions and I have a system of 3 equations, I can say what type of solutions I can have. So we're going to list all the possible solutions that we can have given this system. So if I'm going to scroll up here, and what we're going to do is we're going to go ahead and we're going to let we're going to find 2 possible solutions. And in order to find 2 possible solutions, we have to find the combinations for all our solutions. So to do that, we're going to start by letting z equal a. And you don't have to let z equal a. You could let x equal a. You could let y equal a. It doesn't really matter. You just have to choose one variable to equal a. When I do it, I will most likely always pick z, but it's up to you which one you want to choose to be a. If z is equal to a, I'm going to come back to my other equation. Oops. So I have these equations up here. If I know z is equal to a, I can solve for x in terms of a right away. So I'm going to use that equation down here. So if I know that x plus 2z is equal to 4, and I plug a in for z, I get x plus 2a is equal to 4, so that I can say x is equal to 4 minus 2a. So I know z is equal to a, x is equal to 4 minus 2a. And what I need to do is I need to find y in terms of a as well. So in order to do that, I need to find an equation with y in it. So if I go back up and look at my equations up here, I can take this bottom equation, 5y plus 10z equal to negative 35. I'm going to use this equation in order to get y in terms of a. So if we come back down here, I'm going to take the equation that 5y plus 10z is equal to negative 35. And now I'm going to plug a in for z. So 5y plus 10a equals negative 35. Solving for y, the first thing I have to do is subtract the 10a. So 5y equals negative 35 minus 10a. And then I want to divide everything by 5. So I get y equals negative 7 minus 2a. And now I have everything with y in terms of a. So from here, I can go ahead and find 2 solutions. So when I'm looking for my solutions, I'm using the fact that z is equal to a, that x is equal to 4 minus 2a, and y is equal to negative 7 minus 2a. I'm just going to go in order, so I'm going to throw z equal a here at the end. And then you can pick any number that you want for a. So I'm going to pick some number for a here, and I'm going to plug that same number in here, which will give me a possible solution for my system. So solution number 1, I'm going to let a equal 0. So if a is equal to 0, I know z is equal to 0. I know y is equal to negative 7 minus 2 times 0, which is negative 7. And I know x is equal to 4 minus 2 times 0, which is 4. So I get a solution of 4, negative 7, 0. Remember, your solution must go in order, x, then y, then z. Then if I want to find another solution, so my second solution, I can let a really be whatever I want. So now I'm going to let a equal 1. You could let a equal 2, 3, 4, it doesn't really matter. So if I plug that in, I know z is equal to 1. So then y is going to be equal to negative 7 minus 2 times 1, which would be negative 7 minus 2, or negative 9. And x would be 4 minus 2 times 1, which would be 4 minus 2, or 2. So I get solutions of 2, -9, and 1. Remember, you could all have different answers here if you choose different a values. If you have any questions, please raise your hand. Otherwise, I'd like you to go to the Try This. There will be a separate link for the Try This that you can click on to see if you did it correctly.